Hey everyone, and welcome back. We're going to finish off this week's topic around multidimensional arrays with a video a little bit different with no code. Today we're going to focus in on reference diagrams because a 2D array or a 3D array, whatever it might be, these multidimensional arrays, they're not really grids. They are arrays of references that point to other arrays. So today we're going to look at exactly that. We're going to look at the storage model under the Java hood. Now, as I've done before, you'll see how I draw my arrays, which is basically a fallen ladder. Let's start with just writing one line of code here, just the one, saying we have a 2D array grid, and let's make it equal to a new int array of size 4 rows, 3 columns. Now, what this actually means is we can split our memory diagram in half. And on one side, we'll have our runtime stack. And on one side, we have our heap. Now, on our stack, we have a grid variable. I might as well change colors actually here. We have our grid variable, and it has an address, which is a reference to somewhere over on heap memory. And where is it referencing? Well, it's referencing somewhere over here. Whoops. That's going to look something like this. 1, 2, 3, 4. 1, 2, 3, 4. And we understand that grid is going to point to a 2D array, meaning an array that has a bunch of array spots in it. This is one array with 4 references. So grid is this array. This is the reference to the array. And then each of these spots has a reference to another array of size 3. So we've got 1, 2, 3. I guess I could move these a little closer. 4. And each of these should have 3 elements in it. There we go. And by default, technically, since they are all integers, they all end up with a default value of 0 in them. There we go. So what we can actually see here is that grid does point to this object that was created. And this object here has 4 different arrays living inside of it. So we actually end up with 5 objects being created, even though we are a single 2D matrix. I'm going to make a note here of that. In this example, we have one 2D matrix that was created. We have 5 objects in memory. And we can hold 12 int values. Right? That's each of these spots in here. Okay, hopefully we can see all of that. Each of these references here point to their own arrays in memory. If we extend on the example that we saw in the last video, I'll just switch back over here, where we had code such as this, int array grid. I'll just do it a little bit smaller, 3. And then that's empty. What we saw was that we had grid over here, and it referenced over here in memory a array of size 3, each one with a reference. But of course, we don't actually have any references yet. This is still null. So each of these spots should be null. There we go. Now, once we actually start to make changes and initialize these values, grid at 0 is going to be a new integer array of size 5. And grid at 1 could be a new integer array of size 2. Our drawing will shift a little bit. Our drawing ends up looking something more like this. There's all 3. This first one ends up with an array of size 5. This next one ended up with an array of size 2. And this final one over here is still null. So in this example here, if you were asked questions like how many objects have been created, we can see 1, 2, 3 objects have been created, right? This is still null. It doesn't count as an object yet. It hasn't been created. How many values can we hold in here? Well, it's not quite as simple as before when you could just multiply those two numbers together that were in the declaration and be done. Here we can see we can hold 5 plus 2 and then 0. That's not anything yet. So we can hold 7 integer values, and we have 3 objects that have been created and 1 2D matrix. If we were going to take this one step further and just sort of finish off our example here with modifications, imagine for a second if we added a line of code such as grid at spot 0 at spot 3 equals 2. What actually happens in our code with this is we go to that grid memory address. So the line gets followed over here. Sometimes I'll draw it like as a person, if I'm being kind of silly with this. So first we go to grid at spot 0. So Java is this person right here, and she starts at grid and walks over to spot 0 right here. And then we go and we find spot 3. So Java comes spot 0, spot 1, spot 2, spot 3. So it's this one right here. And then she can slot in the value 2 right there. So we can kind of see exactly what's happening here and why it works for us to pass these in by reference instead of by value into methods. The last thing I'll show off is aliasing. So rather than modifying an existing row, we're going to have 2 arrows pointing to the same row. I did show this in Python Tutor pretty early on, but I will show it here as well with just one more example. Grid at spot 2 is equal to grid at spot 1. Well, what is actually happening here is Java sees that we need to go to row grid at spot 2, and we need to assign it equal to whatever the memory address is for grid at spot 1. So Java climbs all the way into grid, finds spot 1, here's spot 0, here's spot 1, and Java says, what memory address do you have? And it finds the memory address for this array right here. So then it goes over to grid at spot 2 and it says, here, take the memory address. And what does that actually look like? It looks something like this. And now we can see that both grid at spot 1 and grid at spot 2 are pointing at the same piece of memory. This is our aliasing, our shallow copy. And we can see it happening here in a picture as well. This is a pretty common bug when we have 2 references pointing to the same row when we do it unintentionally. And we end up losing data or overwriting data that we actually really needed. So a reminder that while we do draw often our arrays as grids, we might draw it something like this, 0, 1, 2, 0, 1, 2. In reality, they are just arrays of references, and understanding this will prevent issues like aliasing or overwriting data that we actually need. This works even if we wanted to do a 3D array, grid. I'll just show one quick example before we wrap up. Array, 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 grid, new int array, size 3, size 4, size 2. It starts to get tricky, of course, the more dimensions that we add, but it really doesn't have to be terrible. We can understand that grid is going to be an int array, or rather, grid is going to be an 3D int array, which means that grid is going to house 3 2D grids, and each of those is going to house 4 int arrays, and each of those house 2 ints. So we can sort of see how these numbers correspond. Maybe I could even highlight them. The 3 corresponds to how many 2D arrays we have. The 4 corresponds to how many each of those have in the single arrays. And then 2 corresponds to right here how many ints. So if we were going to draw that out, we would have our grid, and it would be of size 4. Each of these is going to be an array of size, oh, I said size 4, but I meant size 3. I'm so sorry. Let's just redo that. Size 3. And each of those ends up being an array of size 4. There we go. And each of those ends up being an array of size 2. Okay. So more great questions for exams spawn from things like this and being able to understand how to draw them, what they look like, what they mean, stuff like that. I'll add just my colors back in. We can see that each of these spots here is the actual ints that we can house. There we go. So how many ints can we actually house? 2, 4, 6, 8. We can house 24 ints. 24 ints in total. And this is also true because 3 times 4 times 2. 3 times 4 times 2 is going, oops, that's supposed to be a 2, gives us that 24 ints in total. So that same trick we used previously still works. How many int arrays do we have here? This is an int array, 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 int array. Those are all int arrays. So we can say that we have 12 int arrays, and that's because we have 3 times 4 in total. And then how many 2D arrays do we actually end up having here? 1, 2, 3 2D arrays. That's just this number directly. 3 2D int arrays. And of course, our one main 3D array. One 3D array. So lots of really interesting questions can be asked about something like this. Often it makes it easiest to just sort of abstract some of this away. So an example may help. Imagine if we wanted to track the temperatures, the record high and record low for every single day in a year. We would need one array with 12 spots. That's going to say stops. 12 spots. And then each of those spots needs to have an array of 30 to 31 days, right? Because that's how many days there are in a month. Days in month. And this one is months in a year. And then for each of the days, we need to have a 2D array for a high temp and a low temp. High and low of each day. And so if we kind of try to ground our understanding in an actual example, and I often find this one helps a lot, we can see that 3D arrays and potentially beyond don't have to be something we visualize in like a 3D space, but rather just a way of grouping our data together. Hopefully this understanding will help you move forward and solve some really interesting problems with multidimensional arrays. Up next is our linked list concept, a really fun but big one. So make sure that you've got a really good understanding of what we've been doing up until now, and I'll see you in the next video. Thanks, everyone.